wrote on the board last time because I want to leave it up here and refer to it. Basically, if you have an inequality that has an absolute value of some, here I have x, but it could be any expression of x, greater than a number, it means that whatever that expression is has to be more than 3 distance units away from 0. So when you have the greater than sign with a number, it means a shaded region away from however many distance units it is. And if you have an absolute value less than a number, it means that that expression is less than 2 distance units away. So plus or minus 2, it's going to be in that interior region there. So we're going to leave it there because we're going to be discussing that as we solve our problem. So our first problem is obviously a little more complicated than those. What if we had 2x plus 5, absolute value of course, and that's less than 3. So the first thing you do is you say, what category does this fall into? It's an expression of x less than a number. So it's an expression of x less than a number. This means that it's less than, in this case for that problem, 3 units from 0. So if you want to visualize it, what you're saying is that this expression of x is essentially, if you want to draw your own little number line here, this is 0, this is 3 distance units in the positive direction, 3 distance units in the negative direction. Since this has to be less than 3 distance units, that expression needs to fit in this region. So it all lines up. We know that we're going to get a segment of shaded region on our number line when we're done with the problem. So the reason we write it down like that is because it helps us remember that this is an AND type of inequality. So we'll have 2x plus 5 has to be less than 3, and this little diagram helps us remember the other constraint is 2x plus 5 less than, let's see here, greater than negative 3. Because this expression less than 3 means coming this way, and this expression greater than negative 3 means it comes the other direction up. So this is the translation of what we had in our original problem statement, because this has to be less than 3 distance units from 0, which we break it out into these two different situations. So now we just solve them individually, just like little equations really, or little inequalities. So we have 2x less than, we subtract 5 here. What's 3 minus 5? Negative 2 on the right-hand side. And then to get x by itself, we divide by 2. So we just go ahead and make that negative 2 over 2, which means x is less than negative 1. So this is one part of the answer. But we have an and. Now we have this guy here. So 2x greater than, we subtract 5 here. Subtract 5 here. What is negative 3 minus 5? Will be negative 8 on the right-hand side. Again, divide by 2, so we'll have x greater than negative 8 over 2, which means x is greater than negative 4. And these are joined, don't forget, by an and. All right, so what we're saying is our solution is going to be when x is less than negative 1, x is less than negative 1, and when x is greater than negative 4. So the easiest way to tackle that is to go up and try to graph it. So neither one of these guys has an equal to sign, so they're going to be open circles. So we're saying less than negative 1, so we go up here and we put a circle on this guy. So less than negative 1 means we would be going this way, but greater than negative 4, which means we have an open circle here. Greater than negative 4, less than negative 1 means we're shading that interior region there. Every little number in this shaded region, other than, of course, not including negative 4 and negative 1, every number in there is going to satisfy this inequality. So you could circle the answer like this, of course, but since you know it's an and, we can write it as a compound inequality. Put our less than symbols, and we read it from the inside out. X is greater than, this is the greater than symbol, negative 4. X is less than, this is the less than, negative 1. So this is the way you would typically write it. There, x is greater than negative 4, also x is less than negative 1, and because we write it like that, we've implied that it's an and. All right, so if you were to pick something in our solution space here, let's say negative 2 worked, right? We're saying negative 2 is one of the solutions of this inequality. What if we put it in here? Negative 2 times 2 is negative 4. Negative 4 plus 5 is positive 1, right? And positive 1 absolute value is also positive 1, which is less than 3, so it works. And if you were to choose a number that's outside of the region we've shaded, of course it wouldn't work. You can go ahead and do that yourself. The easiest one to pick would be 0. What if we put 0 here? 2 times 0 is 0, plus 5, we get 5. Absolute value of 5 is not less than 3, so of course it doesn't work. All right, so half the challenge here is realizing the problem is going to look like a shaded region. We're saying that this expression fits in this shaded region, but we have to solve the inequalities to find out what the actual values of x are that fit in here that make that work. All right, so the next problem is going to be absolute value 1 minus x over 3, close absolute value, greater than or equal to 2/3. Now the only reason that this one's really a pain is because it has fractions everywhere, so you're going to have to deal with fractions. But the first thing we want to do is identify what type of inequality is it. Is it and or is it or? So what we're saying is this expression of x has to be more than or equal to 2/3 of distance units from 0. So when you have a greater than symbol like this, you're in this case where the expression is more than so many distance units. That means that it has to be farther away. It's going to be going in plus negative directions. So it's the opposite case of what we had for problem number 1, which means it's an or type of situation. And if you really wanted to sketch that, you don't have to do this, but you know what we're saying is 0. Here you have 2/3. Here you have negative 2/3. What we're saying is this expression, not the values of x, but the whole expression, has to be either bigger than 2/3 or less than negative 2/3 because it's greater than 2/3 distance units away from 0 in the negative direction or in the positive direction. So we know it's an or. And so what we do is we write it down like that. We say the two constraints are 1 minus x over 3 is going to be greater than or equal to 2/3, or what else could be true? 1 minus x over 3 is going to be less than or equal to negative 2/3. And this little diagram helps me visualize that the two constraints is the expression has to be bigger than 2/3 or less than negative 2/3. That's the only way that the absolute value will be more than 2/3 distance units away. So we solve both of them separately. So we move 1 over here by subtracting, and you'll have negative x over 3 left on the left side, greater than or equal to what we have, 2/3 minus 1 on the right-hand side. But what you have here is, let me switch colors to make it clear. 2/3 minus 1, you can probably do this in your head, but 2/3 minus 1, you can write the 1 any way you want. So I'm going to write it as 3 over 3 because that gives me a common denominator. So what I will then have is, what is 2 minus 3? It's negative 1/3. So what's on the right-hand side of the equal sign is really negative 1/3. So what I have over here, dragging this down, is negative x over 3 greater than or equal to negative 1/3. And then I want to get x by itself. So what do I multiply by on the left and on the right to get it by itself? So let me rewrite this again, x over 3 negative, and then we'll say greater than or equal, give myself some space, negative 1/3 here. What do I need to multiply by to get x by itself? Well, it needs to be negative to kill the negative sign here, and then I have a 3 on the bottom, so let's multiply by 3 over 1, which means that I have to multiply the right by negative 3 over 1 to make it a balanced transaction there. So then what's going to happen? 3 cancels with 3. Negative times negative gives me positive. So I'll have x on the left greater than or equal to, actually what you have to do here, one important thing you don't want to forget. When you do this multiplication in this step right here, we're going to switch the direction and make the arrow point to the left. So when you multiply or divide by a negative, you switch the direction here. Almost forgot to do that. Then you have a positive. 3 cancels with 3, so you really just have a positive 1. So you get x less than or equal to 1. And that is the solution to just 1/2 of this guy. Now we have to go and do the similar kind of thing on the right-hand side for the other one here. So we'll subtract 1 again to move him over, and we'll have negative x over 3 less than or equal to negative 2/3 minus 1. So it's very similar. Here we had 2/3 minus 1. Here we have negative 2/3 minus 1. So just to make sure we don't make any mistakes, because you don't want to make mistakes that are simple, let's go ahead and write this as negative 2/3 minus 1, but I'll write it as 3 over 3. So then I have a common denominator. What do I get here? What is negative 2 minus 3? It's going to be negative 5 on top, thirds. So the answer to the right-hand side, if you're going too quickly, you'll think it's the same thing that you got on the other side, but it's not. It's negative 5/3. So what you have is, on the left, you'll have negative x over 3 less than or equal to, on the right, negative 5/3. And then the rest of the problem proceeds exactly the same. So what you have here is, to get x by itself, we're going to multiply by something. What are we going to multiply by? X over 3, that's a negative sign, less than or equal to negative 5/3. So what we need to multiply by here is negative, let's do it like this, negative 3 over 1. Which means we multiply this one by negative 3 over 1. And that kills the 3 with the 3, and the negatives multiply away to give me a positive. So all I'm left with on the left-hand side is x. But in this step, when I multiply by the -3, I have to flip the direction of the inequality. So I flip the direction of the inequality. On the right-hand side, I get positive, but the 3's cancel, so I get +5. So the answer I get for one of these guys is x is less than 1, and for the other one is x is greater than 5. So you would write it like this: x is less than or equal to 1, or x is less than or greater than or equal to 5. So less than or equal to 1, or x is greater than or equal to 5, and that's the answer. So the question is, how would you plot that? So let's go look at less than or equal to 1 over here. We have an equal sign, so we're going to put a dot here, and we're going to shade this direction, less than or equal to that, or x is greater than or equal to 5. So I go to by 5, put a dot here because it's greater than or equal to, and again, we get exactly what we predicted from originally in the problem. We said, hey, we have to be greater than this many distance units. So the answer is going to look like a shaded region that goes off in two different directions. But here we found out that the actual value of x is greater than 5 that direction, less than 1 in this direction. And that's the solution of the inequality. So you'd write your answer down like that, and then you'd graph it according to what we have done there. So really all of these problems are going to be done that way. You're going to identify if it's and or, you'll split them out appropriately, you'll solve them separately, and then you'll have to write down the solution once you get them to that point. Now, if you get down to a point where you have kind of a weird answer, meaning that it turns out to be all real numbers or something like that, then you'll have to think a little carefully. But in this case, we plotted it and it made sense with what we kind of thought it should look like. In the next problem, it's going to turn out to not quite make total sense once we get down to the answer. So let's go ahead and show you what that one would look like. The next problem is 0 less than or equal to absolute value 4x minus 7. So that's what we have. The first thing I want you to do when you have, notice that this is different. We have the inequality on the left with the number and then the absolute value. The first thing I want you to do is just flip it all around to put it in the same format as what we've seen before. So write it as 4x minus 7 absolute value, and then it has to be a greater than or equal to sign 0. So work with this version because that helps us think about what it should look like. It's a greater than or equal to, but it's the number 0. Now when it's greater than or equal to a number, typically we think of that as being shaded regions that go in both directions, but usually when it's like a number 1, 2, or 3, you know, it's kind of like going from two different points, but here we're saying is greater than 0. So what this is really saying is that this expression for x, whatever it is, has got to be more than or equal to 0 distance units away from the origin. More than 0 distance units away from the origin. So that's kind of weird, and that's why it's kind of good to sketch these things a little bit. So if I do this, this is 0. What we're saying is this expression has to be more than 0 distance units away. So 0 distance units away is right here. So that means more than 0 away in this direction would be all of this, and more than 0 distance units away in this direction would be this. So according to this, it's like the whole number line, really. So it's like a shaded region that goes from here to here and also from here to here. So that's a little bit weird, but that's typically what we consider to be an or. Like if it was greater than or equal to 1, it would be from 1 and from -1, and we would consider that an or type of deal. So let's treat it like an or. So the way you would do that is you would say, you would have 4x minus 7 greater than or equal to 0, or 4x minus 7 less than or equal to 0. So we're saying that this expression has to be bigger than 0 distance units in the positive direction, or less than 0 distance unit, or less than 0 in the negative direction as well. So then we just solve them both, and they're very simple. We move the 7 over by addition, so we get 4x greater than or equal to 7. We divide by x, so we get x is greater than or equal to 7/4. All right, and then we have a similar thing here. We move the 7 over, 4x less than or equal to move the 7 over, we get a 7. And then we divide by 4, we get 7/4, and these are joined by an or. So what we found out is that our solution space is saying that x can be greater than or equal to 7/4, or it can be less than or equal to 7/4. So think about what that means. If you have a number, 7/4, right? Or, you know, let's go 7/4, what is that? 8/4 would be 2, right? 8/4 would be 2. So well, I don't have an 8 over here, but if you imagine that this was an 8, right? Or 7/4 exactly. What we're saying is x is greater than this number, or x can be less than that exact same number. So that means that you're going to be shading the entire number line in both directions, right? like this. Because why? Because 7/4 is just a little bit less than 2. So here's basically 7/4 somewhere over here, right? So we're saying that x has to be bigger than this number, or x can be less than this number. So it ends up being the entire shaded region, which is kind of what we predicted from the beginning, knowing that the expression had to be greater than 0. So it's one of those kind of weird problems. I told you, when you get down to the answer, this is what you're going to circle, or you could just say all real numbers are the solution, because once you actually read your solution, you realize it includes all numbers. Every number you can pick is going to be either bigger than 7/4 or less than 7/4. So the real answer is all numbers, and that's why we did it that way. All right, that's why we did it that way. All right, what I want to do next is one more where we have to really graph it, and then we'll have kind of one little oddball at the end. What if we have t minus 2 over 4, absolute value, less than or equal to 1/2? The first thing we want to do is identify, is this an and or an or type of deal? What we're saying is there's some expression of t that's less than 1/2 distance units away from the origin. So whatever that expression is, if this is 0, this is 1/2, of course this is 1, this is -1/2, this is -1. What we're saying is this expression has to be less than or equal to 1/2 distance units away. So in the positive direction it would go to here, and in the negative direction it would go to here, because this is a 1/2 distance units away either side of 0. So we're showing ourselves that it's an and kind of thing, which is what we come to expect when we have that less than sign like this. So it's an and. And then the next thing we need to do is break it out into the two equations of and that we have. So t minus 2 over 4 less than or equal to 1/2, and the other side of the equation is, or the inequality, t minus 2 over 4 greater than or equal to -1/2. And you can see this from the diagram. So less than 1/2 gives you this, and greater than -1/2 is this one. And then we solve them both separately. Now the only real pain is that we have some fractions to deal with. So the first thing we want to do is we want to get rid of the 4 in the denominator. How do we do that? We multiply the left by 4. Because that will have a 4 up here. It'll cancel. We multiply the right by 4. What will we have? We'll have t minus 2 less than or equal to 4 times 1/2. Multiply the left by 4, it cancels. Right by 4, we get this. So we'll have t minus 2 less than or equal to, what's 4 times 1/2? You'll get 2. And now we're going to move the 2 over by addition, by adding 2. So t is less than or equal to 2 plus 2 is 4. And that's what we get for the one part of the solution. And then over here, we do the same thing. We want to get rid of this 4, so we're going to multiply the left by 4. That's going to just give us t minus 2 because it cancels. On the right-hand side, we'll have the -1/2, and we'll again be multiplying by the 4. So what we'll have is t minus 2 on the left, and here we'll have -2 on the right. And then what we have here, when we add 2 here and add 2 here, we'll just get 0. And we're joining these by an and. We're joining these by an and. So what we're saying is our solution is saying that t has to be greater than or equal to 0 and less than or equal to 4. So if you want to write that as a compound inequality, the first thing you do is you put your t in the middle, you put your left hand and your right hand inequalities. They both have equal signs, so we'll put equal signs under each of them. T is, reading from the inside, greater than or equal to 0, less than or equal to 4. So greater than or equal to 0, less than or equal to 4. This is the answer that you would write. Now let's go ahead and plot this guy. Greater than 0, less than 4. Greater than 0, less than 4. So greater than 0 or equal to it, less than or equal to 4, means we have 2 dots here and we just join them here. Greater than or equal to 0 and less than or equal to 4. The overlap of the 2 is the shaded region that we have. And then we're basically done. We're essentially done. All right. I have time, and I think I have space. I think I'm going to do it right over here, actually. I have room for one more. It's a pretty short problem, so I don't think it's going to matter too much if we cram it in, because it's not that long. But I just want to kind of do one like this to show you. What if we had, for our very last problem, absolute value x plus 5 minus 3 is equal to 1? What is the very first thing we have? Now, first of all, notice right away that this is not an inequality. It's an equal sign. So I just want to do one more like that to show you how to handle it so you don't get tripped up. The first thing you want to do is you want to get everything over to the other side that doesn't involve this absolute value. So let's add 3, killing the 3 here. or the negative 3, and we'll add 3 there. So you'll have x plus 5 is equal to what happens when you add 3, you get 4. And then you have to ask yourself, what does absolute value really mean? It means that whenever the value of what's on the inside of the brackets here, the absolute value brackets, can either be two values. They can either be positive 4, or it could be negative 4, because either way, if I take the absolute value, I'm still going to get 4. So we break it out into two equations. The first one is going to be x plus 5 has to equal 4, and the second one, or x plus 5 is equal to negative 4. These are the only two ways that I could stick either a 4 in there and get 4 on the right, or a negative 4 in there and get a 4 on the right and get an answer. So when I subtract 5, 4 minus 5 is negative 1, or when I subtract 5 here, you'll get negative 9. So the answers I get is negative 1 or negative 9. This is what you would circle on your exam. And to plot something like that, you would literally just go to negative 9, and I can just do this here, since I don't have my thing set up perfectly over there. I have 0, this could be negative 1, way over here would be negative 9, and you just have two dots, one of them right here and one of them right here, and those are your two answers. So it's not a shaded region because it's not an inequality, it's an equation. But when you have absolute values running around equations, it almost always gives you two answers, because the absolute value operation kind of forces you to have two possibilities, either positive on the inside or negative on the inside. And that can yield two different solutions. So make sure you can do all of these. It's been exactly the same skills, but we've just been practicing slightly more complicated problems. We have another batch to give you a little more practice with this, and then we'll call it a day for solving absolute value inequalities. Learn anything at mathandscience.com.